All right, I remember how much you all loved square roots and squares. Today we're talking about cube roots. Yay! Students will be able to identify perfect cubes, then find the cube roots of various perfect cubes, including fractions and decimals. You've learned how to square numbers. For example, 4 squared equals 16. Because when you multiply 4 by itself, or you're multiplying 2 4s, you get 16. To cube a number, you multiply it by itself 3 times. For example, 3 cubed, or 3 to the third power, means you have 3 3's getting multiplied, which is 27. So 4 cubed, which means 4 times 4 times 4, you get 64. 5 cubed, which means 5 times 5 times 5, you get 125. Well, negative 3 cubed, notice the negative 3 is in parentheses. That means you have negative 3 times negative 3 times negative 3. Negative times a negative times negative, odd amount is negative 27. And 0.2 to the third, if you do 0.2 times 0.2 times 0.2, you get 0.008. Well, the reason for that is 2 tenths, 2 tenths, 2 tenths. In the denominator, you really have 10 times 10 times 10, or 1,000. That's why the 8 is ending up in the thousandths place. 3 cubed is 27. So the inverse of that, or the cube root of 27, would bring you back to 3. So the cube root symbol looks just like the square root symbol, except there's a little 3 in the crook, okay? So the radical symbol with the small 3 next to it means cube root, or you would say the cube root of 27 is 3. Notice the answer not under the radical anymore. So the cube root of 8 would be 2, because we're looking for a number that can be multiplied by itself 3 times to get you the 8 that's on the inside. So since 2 times 2 times 2 gives me 8, the cube root of 8 is 2. Well, the cube root of 1 is just 1. It's the only way to get 1 as your final answer. And the cube root of 64 is 4. Why? Because 4 times 4 times 4 will give you the 64 we were looking for. Cube roots of large numbers. So this is going to be similar to our shortcuts we had for square roots. If I want the cube root of 27 million, I take the cube root of 27, and this time I'm going to take 1/3 of the zeros since it is cube root. So start with the cube root of 27, which is 3. Since there are 6 zeros, I only want 1/3 of that, which would be 2 zeros in my final answer. So I'm just going to make a point here. 1/3 of the zeros. So if I want the cube root of 125, and then there's 3 zeros, I would take the cube root of 125, which is 5. And since there are 3 zeros, I only want 1/3 of them, which would be 1 0. All right, cube roots of small numbers. So this works similar to square roots. First thing, cube root of a small number. You want to cube root whatever number you have here at the end. So I would cube root the 27, and you'll only have 1/3 as many decimal places. So this had 6 decimal places, which means my answer only has 2 decimal places, and the 3 is going to go in the furthest. Anything else that doesn't have a number has a 0 as a placeholder. So if I want to do the cube root of 0.064, first of all, it has 3 decimal places. That means my answer, 1/3, will only have 1 decimal place. And the cube root of 64 is 4, goes in that one spot. You can always double check these answers. You can do 0.4 times 0.4 times 0.4. You get 0.064. So cube root of this number, I have the 125 at the end. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number here has 9 decimal places, meaning my answer needs 1/3 of that, only 3 decimal places in my answer. The cube root of 125 is 5. Anything else remaining gets a 0 as a placeholder. Last but not least on this page, cube root of fractions. To find the cube root of a fraction, you can just cube root the numerator and cube root the denominator. So the cube root of 8 is 2. 2 times 2 times 2 would give us 8. The cube root of 64 is 4. 4 times 4 times 4 would give us 64. And our answer is 1/2. Cube root of 1 is 1. That's easy. And the cube root of 1,000 is 10, because 10 times 10 times 10 would give us 1,000. So that's all we have to do. Now, what if I wanted you to do the cube root of, say, -8 over 100? Can you cube root a negative? Yes, we found out above that the answer to something cubed can be negative, so you can cube root negatives. The cube root of negative 8 would be negative 2. 2 times 2 times 2 is 8. Negative 2 times negative 2 times negative 2 is negative 8. And then I would cube root, this should be a 1,000 because I can't cube root 100. Cube root of 1,000 would be 10, and that would be negative 1/5. Now, if I gave you something like that, like 100 instead of 1,000, that does not follow this shortcut. It would not be something I would ask you to do because it's not following the strategy that we're using. All right. So cube roots of negative numbers. I just previewed that on the front. To find the cube root of a negative number, follow the regular rules, but then include a negative sign. Your answer will always be negative because there's an odd amount of negatives. So the cube root of negative 27 is negative 3 because negative 3 times negative 3 times negative 3 will give us negative 27. The cube root of negative 8 we just found on the front was negative 2. Now try this. What is the negative cube root of 64? So there's a negative sign out in front, and we want you to cube root 64. Well, we know the cube root of 64 is 4, and the negative sign out in front would also give us an answer of negative 4. So we want to make sure that we're working to memorize our cube roots as well. This is the first 10 perfect cubes, and the assumption for MSM3 is that we are memorizing the first 16 squares and the first 10 cubes. Now, a cube, where the name comes from, is a three-dimensional shape or three-dimensional figure, and it has a length, a width, and a height. It has 3 dimensions. So if you multiply those 3 together, you get the volume. On a cube, all the sides are the same, so it's the same 3 numbers, in this case, x times x times x, getting multiplied. So we can say volume equals x cubed in this case. So it says if the volume of the cube were 729, so 729 is the volume, notice I'm putting it under the V, equals x cubed, how would we find the length of one side? So what's the inverse of cubed? It is cube root. So we would cube root the left, and we would cube root the right, and we would get the cube root of 729. Notice that's on our list here. It's the 9th number on our list. 9 equals x, and we could say x equals 9 units. Each side of that cube is 9 units long. In this case, it was measuring in centimeters, so we would say x equals 9 centimeters. Mental math challenge, 300 to the third. So the trick, what is 3 to the third? 3 to the third is 27. How many zeros were in 300? 300 had 2 zeros. Well, since we're going to do 2 zeros times 2 zeros times 2 zeros, the answer will have 6 zeros. So it's going to be a 27 with 1, 2, 3, 4, 5, 6 zeros. So you can use this trick to get very large numbers raised to a power. So 80 to the third. If I just did 8 to the third, I'd get 512. It's the 8th number on our perfect cube list. And then 0 to the third, that means I need a total of 3 zeros. 9,000 to the third. Well, first you've got to do 9 to the third. Our 9th number on the cube list is 729. And then we've got 3 zeros 3 times. So we've got 3 zeros, 3 zeros, 3 zeros, because the 3 zeros was raised to the third power. Now 0.7 to the third, that one's a little bit trickier. 0.7 has 1 digit after the decimal point. So our answer is going to have 3 digits after the decimal point. 7 to the third, our 7th one on the list is 343. So 343 takes up all the spaces. I don't need any zeros for fillers. 0.03 to the third, 2 digits in the number times 3, 1, 2, 1, 2, 1, 2. That means my answer is going to have 6 digits. 3 to the third is 27. That only takes up a couple of the spots. All of those other places get zeros for fillers, for placeholders. Now, negative 20 to the third. This is really a negative, and then we're asking you to do 20 times 20 times 20. Because it's not in parentheses, it's a slightly different question than the one with parentheses. Now, 20 times 20 times 20 is 8 with 3 zeros, and then the negative gets applied at the end. This one says negative 20 times negative 20 times negative 20 raised to the third. There are 3 sets of negative 20. Negative times negative times negative, there's an odd amount. It also comes out to 8,000. However, they mean something slightly different. How is squaring with negatives different? Well, this first one, because it's in parentheses, negative 9 times negative 9, negative times negative is going to leave you with a positive 81. And this one has the negative out in front, and you're going to do 9 times 9, which is 81 in the parentheses, or negative 81. So it makes a difference when you're squaring. The final answer will be positive if it is a negative 9 times a negative 9 inside the parentheses, and it will be a negative if the 9 is negative but without the parentheses. Happens to be that in cubing, doesn't matter. See you in class.